Hey, what's up guys? Today we're going to be multiplying and dividing values that are in scientific notation. So before you check this out, you're going to want to be comfortable with scientific notation itself, as well as your exponent rules for multiplying and dividing powers with like bases. Alright, here we go. Alright, so we're going to start by multiplying values that are in scientific notation. And it's important to notice that this is just one giant chain of multiplication, right? This means 2.8 times 10 to the third times 9.7 times 10 to the fourth. And so there's no addition, there's no subtraction here, it's just one giant chain of multiplication. And the reason it's important to note that is because we can take advantage of the fact that multiplication is commutative. And what that means is that we can reorder the product however we want. And so what I'm going to do here is I'm going to put the two factors that were in front of the scientific notation out together. So we're going to put those first, the 2.8 and the 9.7. And then we're going to multiply that by our powers of 10 here. And so really all we have to do here is just multiply these two values, multiply our powers of 10, and then multiply them together. So you could use a calculator or do this by hand, but 2.8 times 9.7 turns out to be 27.16. And then to multiply our powers of 10 together, we can just use our exponent rule. Since we have like bases, the base is 10 in both of these powers, we can just go ahead and add the exponents together. And so we get 10 to the 7th here. And so while this is absolutely a correct answer, it's not in scientific notation, and more often than not you're going to be asked to put your answer in scientific notation. And so remember, scientific notation, we're only allowed one non-zero digit to the left of the decimal, and here we have two, right, because we have 27. And so to make it only have one non-zero digit to the left of the decimal, we have to move this decimal to the left, right? We want it to be 2.716 and not 27.16. So I've technically divided this whole number by 10 by moving the decimal to the left once, and that changes the value, right? But we don't want to change the value, so we have to make up for the fact that we divided by 10. So since we divided by 10 to move the decimal to the left once, we have to multiply by 10 as well to make up for that. And so multiplying by 10 would be the same as just increasing this exponent by 1. And so we're going to rewrite this value as 2.716, right? That's us dividing by 10, moving the decimal to the left once. And then to make up for that, we're going to multiply by 10 by increasing the exponent by 1. And so this is going to be your answer in scientific notation. Okay, so similarly in this example, again, since this is just one giant product, I can perform the multiplication in whatever order I want. And so I will start by multiplying the 6.8 times the 9.3, and that's going to give me 63.24. And now I can multiply my powers of 10, and since these are like bases, again, I can just add my exponents together, and so I get 10 to the 12th. And this is not in scientific notation, so in order to make it scientific notation, once again, I have to divide by 10 to move my decimal to the left once, so that I can get my decimal between the 6 and the 3. And then since I've divided by 10, I'm going to make up for it by also multiplying by 10. And so I'm going to increase my exponent by 1. And so I'm going to end up with 6.324 times 10 to the 13th power. Okay, and that's really all there is to it for multiplying in scientific notation. So now we're going to divide values that are in scientific notation. So similarly, I can treat these separately. I can just divide the values out front, and then I can divide my powers of 10, and then multiply those two things together. And the reason that works is because right now we have a product, meaning a bunch of multiplication, divided by another product. And so we can always rewrite that as the first factor in the product divided by the first factor in the denominator. And then we can multiply that by the second factor in the numerator divided by the second factor in the denominator. And the reason we're allowed to do this is because this is how multiplying fractions works, right? When we have a fraction multiplied by another fraction, we just multiply the numerators together, and then we multiply the denominators together, right? And so the 7.2 times the 10 to the 8th becomes this, and the 3.6 times 10 to the 5th becomes the denominator. So we can split this into this, and this allows us to treat these independently. And so 7.2 divided by 3.6, we don't even need a calculator for that, that's just 2. And then 10 to the 8th divided by 10 to the 5th, well, we have like bases and we're dividing, so we can just subtract the exponents. So this is going to be times 10 to the 3rd. And that is already in scientific notation. All right, so similarly down here, I can treat this part of the fraction separately from this part and then just multiply at the end. So I'm going to type, 7.584 divided by 7.9 into a calculator, and I get 0.96. And then I can divide my powers of 10 here, so I will just subtract my exponents, and I get 10 to the 4th. Now this is not in scientific notation because I don't have a single non-zero digit to the left of my decimal. So in order to get a single non-zero digit to the left of the decimal, I have to take my decimal and move it to the right once, because I need to get that decimal between the 9 and the 6. And so what I've done here is I've multiplied by 10, right? Because if I'm moving my decimal to the right once, it means I'm multiplying by 10. So in order to make up for that, I also need to divide by 10 so that I don't actually change the value of the number. And dividing by 10 will drop my exponent by 1. And so I can rewrite this as 9.6, right? That's me multiplying by 10 and moving the decimal to the right once. That's where the 9.6 comes from. And then to make up for that, I'm going to divide by 10 as well. So I'm going to drop my exponent by 1. And I'm going to get 10 to the 3rd power. And now this is an answer in scientific notation. All right, and with that said, guys, this has been demonstrated.